Okay, here we've got a question where it asks us to, well, it gives us a function that asks us to find the gradient of the tangent at a particular point, which it gives us this point. Okay, so first step, it says gradient, so we want to find the gradient function, i.e. dy by dx. So we differentiate f of x, actually let's call it f dashed of x. F dashed of x equals, so 3 times 2/5 x squared. Yeah, that's also 6/5 x squared. Okay, now we want to substitute in our value of x that it gives us, which is 1. So we have f dashed of 1 equals 6/5 times 1 squared, which is 6/5. Okay, so now we've done that part. We found the gradient of the tangent to this curve, this one, at this point where x is 1. Part A done. Okay, part B slightly different. We're now asked to find the coordinates of the points where the gradient of the tangent of f of x is equal to 30. Okay, so we want to find where f dash of x is equal to 30. And yeah, just to clarify this, the gradient of the tangent is the same as the gradient of the curve at that point. So if we've got like some curve and we've got a tangent like this, then at this point the gradient of the tangent is the same as the gradient of the curve. That's what a tangent is. Okay, so we've got f dashed of x equals 30. We know what f dashed of x is. It's 6/5 x squared, and that's equal to 30. Okay, so now we've got, therefore, x squared equals 30 times 5/6. So we cancel this becomes 5. So we get x squared is 25. Therefore, x equals plus or minus 5. And to find y, we substitute back into f of x. So this one, this f of x. Okay, so y is, right, so when x equals 5, y equals 2/5 times 5 cubed plus 1, which is 2 times 25, so 50, plus 1, which is 51. And when x is minus 5, y is 2/5 times minus 5 cubed plus 1, which is minus 50, plus 1, which is minus 49. So our two sets of coordinates are, this one gives us 551, and this one gives us minus 5, minus 49. So these are the two coordinates of the point where the gradient of the tangent is equal to 30. Okay, now part C is essentially the same as part B, but they're just telling us it in a kind of cryptic way that we have to unravel. So it's saying find the coordinates at the point where the gradient of the tangent to f of x is parallel to this line. Okay, so we want to rearrange this line to the form y equals mx plus c. So for this line, that will give us, so we can write 5y equals 24x plus 15. Therefore, in this form, it's y equals 24/5 x plus 3. Okay, so now when it's in this form, we can just read off the gradient. It's m. And so here, gradient equals 24/5. So now we're looking for where f dashed of x, this, is equal to 24/5, just like we were doing in part B. Okay, so we write f dashed of x equals, whatever it was, 6/5 x squared, and that is equal to 24/5. So now I can multiply both sides by 5, then we get 6x squared equals 24, and I can see where this is going. Therefore, x squared equals 4, therefore x equals plus or minus 2. Okay, and then you substitute these two values of x into f of x to find y. So you'll get one of the y values will be y is 2/5 times 2 cubed plus 1, and the other one is 2 over 5 times minus 2 cubed plus 1, and I can't bother to do them, but you know, in the exam you would work out what they are. Okay, now final part of this rather long question. Part D, it says to find the stationary points, the coordinates of the stationary points. Okay, so at stationary point we know that dy by dx equals 0, but I keep forgetting in this case we've got f dashed of x, not dy by dx. So f dashed of x is 6 over 5x squared, and this is equal to 0, therefore x is equal to 0. And then we're not done because it asked us to find the coordinates, so we need to find the y values for which this is true. So we substitute in x equals 0 into f of x. So f of 0 equals, 2 over 5 times 0 plus 1 equals 1. So our coordinates are 0, 1. And we finished this question.